Hi everybody. So the next section we're going to look at is section 8.2 on the distribution of sample proportions. So we looked at the distribution of the sample mean in the last section, and so now we're going to look at population proportions, or percentages of the populations that have a particular characteristic or not, and their distributions. So the objectives in this section will be to describe the sampling distribution of the sample proportion, to compute the probabilities of a sample proportion. So as far as describing the sampling distribution of a sample proportion, what we want to calculate in this case, first of all, is the point estimate. And so the point estimate is basically just a proportion of the population that has a particular characteristic. And we will denote it by P with a little arrow kind of on the top. That's read P hat. And the sample proportion is a statistic that estimates the population proportion P. So here's an example. So let's say at a particular university, 1,745 registered voters were asked whether they approved of the way George Bush is handling the economy. 349 responded yes. And let's say we want to obtain a point estimate for the proportion of registered voters who approved of the way Bush is handling the economy. So basically what you do in this case is just take the total number that respond yes, divided by 1,745, and that'll give you about 0.2 or 20%, right? We could have asked this the other way around, right? We could have also asked how many disapprove, and that would give you like 0.8%, right? So it all depends on what you're asking. Here's another example. So according to a time poll conducted in 2008, 42% of voters believe that gay and lesbian couples should be allowed to marry. Describe the sample distribution of the sample proportion for samples of size n equals 50, or 10, 50, and 10. And we're just going to use simulations in this case to create histograms here. So I think you'll see, again, like we saw before, that as the sample size increases, one thing you'll notice that we noticed in the last section is that the distribution becomes more and more normal, right? In the center of the sample distribution of the proportion equals the population proportion P, and the standard deviation of the sample distribution of the sample proportion decreases, right? The spread decreases as the sample size n increases, because as we draw larger samples, again, it'll get closer and closer to the actual population proportion. So as far as the standard deviation for a particular population proportion, the shape of the distribution will be approximately normal if the number of samples times the probability of success times the probability of failure is greater than or equal to 10. The mean of the sampling distribution is equal to the population proportion, and the standard deviation of the sampling distribution will be given by this, right? The proportion of successes times the proportion of failures divided by the sample size, and then take the square root. So again, you'll see that the standard deviation does depend on the sample size, as it did in section 8.1. A lot of times you'll sort of be able to assume, or I'll state that you can assume that this holds, but technically this is something you should check, is that n times p times 1 minus p is greater than or equal to 10. But if I say you can assume that all assumptions hold, right, you can assume that that holds automatically. So the model in the previous slide requires that a couple other things also, that the sample values are independent, and to do this you can basically do this by verifying that the sample is not larger than 5% of the population. Again, that will largely be things we'll assume anyway, so again, a lot of times things you won't have to check on the exam. So let's look at an example here, going back to this time poll. So suppose that we obtain a random sample of 50 voters and determine which voters believe that gay and lesbian couples should be allowed to marry, and describe the sampling distribution of the sample proportion for registered voters who believe that gay and lesbian couples should be allowed to marry. So in this case, the sample size is 50, which is quite a bit less than 5% of the U.S. population. Again, a lot of these things you won't necessarily have to check, maybe on the homework, but not so much on the exam. But if you take n times p times 1 minus p, you do get something larger than or equal to 10. So that means we can use this formula for the standard deviation. So take the probability of success, 0.42, times the probability of failure divided by 50, take the square root, and that gives you about 6.98%. And that's very close to the standard deviation of 7.2% found using simulations. Okay, so let's look at objective 2. So objective 2 in this case will be to compute probabilities of a sample proportion. And so let's look at an example here. According for the CDC, 18.8% of school-aged children ages 6 to 11 years old were overweight in 2004. If a random sample of 90 school-aged children ages 6 to 11 years old was taken, what is the probability that at least 19% are overweight? So that's question A. And for part B, suppose a random sample of 90 school children is taken, results in 24% overweight children. What might we be able to conclude from that? So again, you should double check a couple things, right? That the population is less than 5% of the population. Again, double check this, right? So which is greater than or equal to 10. So again, if those two conditions are met and the populations are independent, you can use this formula for the standard deviation. And so that gives you 0.042, 0.0412. So if you plug that into the formula for the z-score, right, you can assume that if this is greater than 10, that the population is relatively normal. So using the normal distribution here, you get a z-value of 0.0485. Just rounding that up to 0.5, you'll see that you get 0.4801, or about 48.1%. For part B, in this case, the proportion is 24 out of 90, so that's your score. Plug that into your table here again. You'll notice that these two are the same that we had in the previous slide, right? 0.18 and 0.0412. That gives you a z-score of 1.1 or 1.91. So the probability that the z-score is greater than 1.91, again, you'll have to look this up in table 5 or use StatCrunch. And again, if you look it up in the table, right, you'll get this number. So since you want it to be greater than 1, you'll have to take 1 minus the probability, which gives you 0.028. And so we would expect that about 3% or 3 in 100, resulting in a sample proportion of 2.667 or more. This is unusual, right, because it's less than 5%. All right, well, hopefully that gives you guys sort of an idea of what to do there for that section. And that's all there is to chapter 8. So if you guys have any questions or anything about that, just let me know, and then we'll move on to chapter 10. Or 9, sorry.